We are doing NEET questions which were asked in 2015 all over the country. Okay, see this question. It says energy, velocity and time are chosen as fundamental quantities. What is dimensional formula of surface tension? हमको dimensional formula निकालना है surface tension का. So what we are supposed to know is what is the formula for surface tension. The answer formula for surface tension is force upon time, force upon length. We all know that if there is a surface and it is full of all molecules, we draw a line here, then the force between the molecules is surface tension, and this tension, this is the force which is surface tension. And how do we calculate surface tension? We take this length and the total force of all the molecules divided by length. This is in principle surface tension. Now this surface tension should have a certain dimension. What are the dimensions involved in the dimension of surface tension? That is dimension of force, dimension of length. So surface tension has dimensions of mlt minus 2 upon L. So this is m1, L0 and t minus 2. These are the dimensions of surface tension. Now it is to be expressed in the form of energy, velocity and time. Energy E, velocity V and time T. This surface tension has to be expressed in this way. We know this method. E to the raised to the power of A, V to be raised to the power of B and T to be raised to the power of C. That will be the surface tension. This is the required formula. This is required relation. Okay, now surface tension has dimension m1, L0, t minus 2. This is equal to energy ml2, t minus 2 to the power A. Velocity is L t minus 1 to the power B and time t to the power C. Simplifying this, m to the power A, L to the power 2A here, L to the power B here and no L here. Then t minus 2 into A minus 1 into B plus C. This is surface tension which has got dimensions m1, L0, t minus 2. Now equating both sides, that means equating similar quantities. Power of m is 1, power of m is a. So a is equal to 1. We got the value of a. Now L to the power 0, L to the power 2a plus b. So we have 2a plus b is equal to 0. Okay. Third, minus 2a minus b plus c. This is power of t and power of t is minus 2. So this is equal to minus 2. Okay, then simplify this. We put a is equal to 1 here and this becomes b is equal to, a is equal to 1, it goes here, b minus 2. Now we put here a is equal to 1, minus 2 minus b, b minus 2. So this is minus 2 and minus plus 2 plus C is equal to minus 2. So this is cancelled. C is equal to minus 2. Now we have got A, B, C, and this we can write as surface tension is equal to energy to the power 1, velocity to the power minus 2, and time to the power minus 2. And now we check in these solutions which are given to us, and this will be coming to, right, this is C. Option number C is the correct option. So this is, we have used formula ABC. You have done practice of this, and this was asked this year. Thank you. This question says, find out dimensions of permeability. Now permeability dimensions, whenever we want to find out dimensions of something, then we should think of a formula which is having this particular term and the term of force or work, because we know their dimensions. So magnetic permeability, do we have any formula for something which has got mu in it, and that is related to either force or energy? So this should come to our imagination, this should come to us, that we remember a formula of force between two parallel current carrying conductors. This is carrying current I1, this is carrying current I2. There is the distance between them, D. And then we know the formula for force. Force is equal to mu naught upon 4 pi, and here it is 2 I1 I2 upon D. So this is the formula which has got force and which has got mu. So whenever we want to find out dimensions of any unknown quantity, try to find its relation with force or work, because we know their dimensions. So now we put the dimensions here. The dimensions of force, M, L, T minus 2. Okay, dimensions of mu, this we have to find out. Dimensions of 4 pi, no dimensions, we will not write anything. 2, no dimensions. I1, I2. I1, I2 has the dimensions of electric current, and we can write it A divided by distance is dimensions of L. So now mu is equal to, dimensions of mu are equal to dimensions of M, dimensions of L, dimensions of T minus 2 divided by dimensions, 2 dimensions of A, and this L will go up here, and this we can write L. So this is M, L2, T minus 2, A minus 2. And now we will see, do we have any choice here? Answer no. Because here they have used a basic quantity, charge, that is Q, in terms of Q, not in terms of ampere. So we must convert ampere into charge, and we know the relation is current in ampere is equal to charge divided by time. Current is charge upon time. This we have taken current, so this we can put as Q upon T minus 2 minus 2. Okay, let us see. T minus 2 divided by T minus 2. They cancel up, and this will be ML2 Q minus 2. Now see, do we have something like this? Answer is yes. It is answer number A. So if it is given in the fundamental quantity as current, we will mark it current, taking it A. If it is given in the fundamental quantity of charge, writing Q, then we will convert current into Q upon T. So this is how we got it. Okay, let's go to the next question. Similarly, we have to find here dimensional formula of electric flux. Now, electric flux. First, we remember that flux is equal to EDS or E into area. Okay. Now, it's always better to connect the quantities with force or work because their dimensions are well known to us. Now, we have to find the dimensions of flux. So, we must know the dimensions of E and dimensions of A. Now, dimensions of E. Do we have any relation of E with force? Answer is yes. It is force per unit charge. Force on unit charge is known as electric field intensity. This is to be multiplied with area. So, this is mL T minus 2, area L2, and this is Q minus 1. Now, we will see in the question whether they have put charges or they have put current. Okay. Here you see they have given current in terms of I, so we should also change this charge into I. How can we change charge into I? So this will be mL T minus 2, L2 and L1, let us mix it here, L3, and this Q. Q, we know it is current into time. Charge is equal to current into time. So this we write as I minus 1 time minus 1. Charge is equal to current multiplied by time. Both are having power minus 1 minus 1. Now, this is m L3 T to the power minus 3, and this is current I to the power minus 1. And see, does it match to anything? So, this is option number A. So, this we got the option here. Again, we have converted the required quantity into terms of force and then we could find it. So, remember this technique. Now, we go to the next question here. This question says, okay, read it, and F is equal to this, find the dimensions of A upon B and C upon D. That means we should know the dimensions of A, dimensions of B, C and D. Okay, let's go for that. First thing, sine of an angle. This is a quantity which has no dimensions. No dimensions of mass, length and time. So it has no dimensions. But T is having a dimension of time. X is having a dimension of length. So how it can have no dimensions? Answer is C, dimensions of C multiplied by dimensions of T. This should have no dimensions. That means, what are the dimensions of C? The dimensions of C are T inverse. Okay, this is the dimensions of C. Similarly, multiplying the two should have a quantity of no dimension, that is angle. So if this is having no dimension, similarly D, dimensions of X, this should have dimensions of a number, no dimensions. Then D is equal to minus 1. So these are the dimensions of C and D. Okay, this will very well give us this answer. Okay, we will do it. First, we also have to settle for A and B. A and B are very easy. What are the dimensions of sine CT? Answer, sine of any angle is a fraction and it has no dimensions. Now because it has no dimensions, then this is one term, this is another term, this is another term. there are three terms in this relation, and our principle of homogeneity says that all the terms in an equation should have same dimensions. Okay, that means dimension of this term and dimension of this term are same. But in this, what are the dimensions of A sin Ct? Dimensions of A and dimension of sin Ct, that is no dimension. So that is 1. We don't write it. Dimensions of A are equal to dimensions of F. That's right. Now what about this? This term has the dimensions of F, where cos of any angle has no dimensions. So dimensions of B are dimensions of F. Now A upon B have similar dimensions, F upon F. That is 1. Now whose dimension is 1? Answer: M0, L0, T0. That is dimension 1, because both are having same dimension. Or you can write it other way. This is M L T minus 2 upon M L T minus 2, and when you operate it, then this will be 1 minus 1, 0, 1 minus 1, 0, minus 2 minus 2 is 0. This is A upon B. Now C upon D, this is having dimensions C, D, T minus 1, and this is X minus 1. So this is dimensions of X and dimensions of T. X has dimension L and this T has dimensions of T minus 1. Denominator comes here. What about M? There is no M, so we can write it here M0, or we can write it here M0 L1 T minus 1, and now we see this combination. This is available as option number A. So this is how we can do it, and let's go to the next question. See this question. It says, what is the wrong unit conversion? And there are many unit conversions given here. First is angstrom, 10 to the power minus 10. This is correct. 1 Fermi, 10 to the power minus 15. That is also correct. Third is 1 light year, 10 to the power 15. Yes, we remember, this is also correct. Then 1 parsec. 1 parsec is given as 3.08 into 10 to the power 16 meter. That is also correct. And 1 astronomical unit, which is a very large unit of the length, and that is given as 10 to the power minus 11. And this is the mistake here, because if it is very long, then it should have the positive power of 10. So we know that 1 astronomical unit is basically 1.496, or that is 1.5. 1 AU is equal to 1.5 into 10 to the power plus 11, and here it is given minus 11, so that is the odd man out, that is the wrong answer, and we have to select that wrong answer, and that is answer number D. So sorry, E is the wrong answer, so our option chosen will be E. Thank you. It was only a test of our memory, whether we remember. See the quantities here. Again, it is only a test of our concept, whether we are clear about it. The first quantity is weight of a body. Weight of a body is mg, and we know this has got a direction. So this is a vector quantity. So it is not scalar. Second is temperature gradient. Temperature is a scalar quantity, but when we say gradient, suppose here temperature is 100, here it is 90, here it is 120. So the temperature gradient in this direction is 10, 100 to 90 minus. Temperature gradient in this direction is positive. So in different direction, the value is different. So when we say temperature gradient, then it has direction. When we say only temperature, then it is a scalar quantity. What I was telling you, here is a 100-degree temperature and here 90, and this layer of the liquid, this has got temperature 80. Now the gradient in this direction is 20, the gradient in this direction is 10, temperature here is 90, temperature here is 180. This temperature, this and this are scalar quantities, but when we say here it is decreased by 20, this gradient is 20. So gradient has got a direction. Therefore, this is also not a scalar quantity, it has got direction. The third quantity is elementary area. Elementary area, and area we already know that it is a vector quantity. This is say length, this is width, so length cross width. This is area, so we know cross product of the vector always gives a vector. Then what is the direction of this vector? This is the direction of this vector, area vector. This is I cross j is equal to k. So area vector is again a vector quantity. Then next thing given is magnetic strength, magnetic field strength. Any field has got a direction. Field strength, whether it is magnetic field, whether it is electric field. So here magnetic field strength is a vector quantity, it is not a scalar quantity. The next and the last thing, that is option E, that say electric potential. What is electric potential? Electric potential, V is work done for carrying a unit charge. Okay, different definitions, but every time it is work done per unit charge. Work upon charge, it is how it is calculated. Now this is a purely scalar quantity and this is a scalar quantity, and this is to be brought from infinity. There is no direction as such. So potential has no direction, it is a scalar quantity. So out of all this A, B, C, D, E, only quantity A, potential, which is a scalar quantity. So our option is E. This is the scalar quantity. Thank you. Let's go to the next question again. Okay. See here, match the columns. So it appears to be a very popular method of a question, but solving it, we must know dimensions of each and every quantity here. So the first is electrical resistance. Resistance. So we must remember the dimensions of resistance, and the dimensions of resistance are, if you remember it by memory, that is best. Certain electrical quantities you must remember the dimensions. Which are those electrical quantities? Electric charge, electric current, potential, electric field. Of course, electric field is in electrostatic, and yes, magnetic permeability and electrical permittivity. These are few things you must remember for dimensions. Anyway, if you remember the dimensions of resistance, these dimensions are ml2 t minus 2, ml2 t minus 2, and ml2 t minus 3, and ampere A minus 2. These are the dimensions of resistance. If you remember, it's fine. Otherwise, you can make it as resistance formula V upon I. V is what? V is work per unit charge. Work per unit charge into I, because we are converting into the fundamental dimensions of current I. So this Q we should also convert to I. So this is ml2 t minus 2. Work divided by Q is equal to I multiplied by time. I multiplied by time, and there is another I, and I has got dimensions A, so I will convert it into A. There is a mix up here. ml2 t minus 2 upon a2 and t, and this is equal to ml2 t minus 3, this and this t minus 3, and a minus 2, and you see this has come. So if you do it by memory, it's fine. Otherwise, you can solve it this way. Resistance. Now, see for the second quantity. The second quantity is electric potential. And we all know potential is equal to work upon per unit charge. So, V, potential. Work per unit charge. This work is ml2 t minus 2 upon charge is I multiplied by t. So this is equal to ml2 t minus 3 I minus 1. This is potential. Now we go for the third quantity, that is specific resistance. Specific resistance, do you remember? Yes, we know that specific resistance rho and R, it has got a relation, that is resistance R is equal to rho into L upon A. This is the formula wise, okay? So rho is equal to R into area upon length. The unit, the dimensions of R, we have already done here. This is ml2 t minus 3 a minus 2 into area L2 upon length L1. So this becomes L2 and 2 4 minus 1 3 t minus 3, that's all, minus 3, and A minus 2. This is specific resistance, and the fourth is the specific conductance. The specific conductance is 1 upon specific resistance, that is inverse of it. If this is inverse of this, then this will be m minus 1 L minus 3 T plus 3 and A plus 2. These are the dimensions of specific conductance, and now we have to match it, and you see here how we can match it. Okay, so A matches with 2. A match with 2. See B here, try to match up. B is potential ml2 t minus 3, and that matches with number 3. Then C is specific resistance, that match with this is C, A, B, C, and this is D. See this is the very first one, so C matches first one, and D 4, because you see these dimensions are nowhere there, so this is D matches 4. This is how we can do it. Thank you. Yes, mass of liquid flowing per second per unit area of cross section of the tube is mass of the liquid flowing per second per unit area. Mass of the flowing per second time per unit area of cross section of the tube is proportional to okay, or we can write it, the dimension will be equal to, okay, pressure difference to the power n, pressure difference to the power n, and average velocity to the power m, average velocity to the power m. This is question given to us. If these two are proportionate to each other, then their dimensions of both the sides should be equal. So dimensions equal. Now what are the dimensions here? M. This is per unit time T, per unit area L2. This is left hand side. On the right hand side, this is pressure. Pressure is force upon area. Force is mLT minus 2 divided by area L2, and this has power n. This is V is given to us as average velocity. Velocity is Lt minus 1 and it has got power m. This is what is written in the text, translated into physical language, physical quantities. Now equate. So this is m to the power 0, L to the power 2 and T to the power L to the power minus 2 and T to the power minus 1 is equal to, here it is m to the power n, L to the power, this we cancel out, so this is L minus 1 into n, that is minus n, ml T, okay, T minus 2 into n minus 2n, and here it is L to the power m and T to the power minus m. Again we simplify this and this comes to m to the power n L to the power minus n and L to the power minus n and L to the power n, and T to the power, here T minus 2n minus m, minus 2n minus m. This is the equation we have got. Here m to the power not 0, m to the power 1, correction. Okay, this. If we have done it this way, then can we find the value of n and m? Check the answers. We have to find the relation of m and n. Okay. Here if you put it minus 2 into plus 1, that is minus 2, and this is minus 2 plus 1, that is equal to 1, this is minus 1, correct. So these are the values of m and n. Now when we got these values of m and n, we are not asked about it. हमसे m और n के लिए नहीं पूछा जा रहा है, हमसे क्या पूछा जा रहा है, डिफरेंट रिलेशंस. जैसे क्या m इज इक्वल टू n है, ओके, पहले हम लिख लेते हैं m इज इक्वल टू -1 एंड n इज इक्वल टू +1. ओके, फर्स्ट रिलेशन A, m इज इक्वल टू n. A, m is equal to n. No. B, C, m is equal to minus n. m is equal to minus n. इसको माइनस करिए, ये इसके बराबर हो जाएगा. So this is the right option. Then option C is m square is equal to n. m square is equal to n. That is also correct. And D, m is equal to minus n square. m is equal to minus of n square. That is also correct, but that will not stand scrutiny here. So this is the first and the right answer. So if we have to choose only one, we will choose answer number B. Thank you. See this question. F is equal to AT plus BT square, and what are the dimensions of A and B? It is a very simple question of homogeneity principle. Homogeneity principle say that dimensions of each term are same and how many terms are there. Every quantity between plus and minus is one term. So here this is one term, this is one term, and this is one term. Now dimensions of all the terms have to be same. Do we know dimension of any one term? Answer is yes. We know the dimensions of f. f के डायमेंशन हमको पता है, और f के डायमेंशन कितने होते हैं? m l t minus 2. इसलिए at के भी डायमेंशन क्या होंगे? a इसके डायमेंशन हमको पता लगाने हैं, और t टाइम का डायमेंशन t. So what are the dimensions of a? Answer, dimensions of a are, t को इस तरफ ले आइए, this will be m l t minus 2, और एक ये नीचे आएगा, that will make it minus 3. These are the dimensions of A. Now what are the dimensions of B? So similarly again m l t minus 2 have the dimension B and dimension of t, that is 2. So B has the dimensions of m l 2 goes here, minus 2, sorry 2 goes here, and that minus 2 will become minus 4. So B has the dimensions m l t minus 4, and now you can check with the answers. With answer it matches with, the answer it matches with very first option, that is option A is the correct answer. And now we go to the next question. This question says the ratio of dimensions of Planck's constant and moment of inertia I. Moment of inertia. Okay, we have to find out the ratio of their dimensions. Let's find out dimensions individually. प्लैंक्स कांस्टेंट की डायमेंशन हमको कहाँ से मिलती है? बहुत फेमस फार्मूला है, एनर्जी इज इक्वल टू h nu, where nu is frequency. Frequency has got dimension t minus 1 and energy has ml2 t minus 2. So h is having dimensions of ml2 t minus 2, and this will come here minus 1, this will go there plus 1, and this will be t minus 1. These are dimensions of Planck's constant h. Then this is moment of inertia. Moment of inertia I, it has a formula mr square. This has dimension m1, r is radius, radius has a dimensions of length, and length to the power 2, L2. Okay, now ratio of the two, h I, this is equal to ml2 t minus 1 upon ml2, this is equal to t minus 1. So this is our option number A. Again, this is dimension of frequency. So this is how we can solve it. So you have seen that in dimension and this thing, dimensions is the more popular in questions. So in this year, all the questions from all the boards are from dimensional analysis only. Thank you.